1,000 little cubes stacked into one big cube, 10 along every edge. Now peel the whole outer shell off it. Every cube that touches the outside comes away in your hand. The faces, the edges, the corners, all of it. How many cubes are you holding? Answer before I say anything else, because whatever number arrives first is probably wrong. And here is the part that stings. It is not wrong because the arithmetic is hard. Most people who miss this do the arithmetic perfectly. They cube correctly, they subtract correctly, and the number they hand over is still not the number of cubes on the floor. The mistake happened one step earlier, in the picture they drew. Here is the number almost everyone says: 271. And the reasoning that produces it sounds completely sane, which is exactly why it is dangerous. A shell is 1 cube thick. Take a layer off a side of 10, and you are left with a side of 9. 9 cubed is 729. 1,000 minus 729 is 271. Every step there is correct. 10 cubed really is 1,000. 9 cubed really is 729. And the subtraction is right. Nobody fumbled the multiplication. So if the calculation is clean, the fault has to be in the picture it was calculating from. Read the middle line again, slowly. 10 becomes 9. Where did the other end of the block go? That question has a family. You start finding this shape everywhere in a screen. A border on a grid, a window inside an array. Same slip, different clothes. I have watched hundreds of candidates take exactly this turn. The ones who recover had met the shape before. So I collected them. The Quant interview playbook is 281 worked problems, each solution naming the move before it touches the algebra. Link is in the description. Now, the other end of the block. Drop a dimension for a second. Slice straight through the middle of the block, and you get a 10 by 10 square of little squares. Same problem, flat enough to check by hand. Peel the border off that, and watch one row from the middle while it happens. 10 squares in the row. The one on the far left is on the outside, so it goes. And the one on the far right is on the outside too, so it goes as well. The row does not lose a square. It loses a square at each end. 10 becomes 8. That is the whole problem, and it is worth saying slowly. A shell really is 1 cube thick. But it wraps all the way round, so on a row through the middle of the block, it bites at both ends. Now count the flat picture. The border of a 10 by 10 square is 36 squares. What is left in the middle is 8 by 8. 64 standing, 36 gone. The reflex would have said 9 by 9, and you can see with your own eyes that it did not. Now put the third dimension back. The same thing happens on all 3 axes at once, because the shell wraps the block in every direction. Left and right, front and back, top and bottom. Each axis loses 1 cube at each end, so 10 goes to 8 on all 3 of them. What survives in the middle is not 9 by 9 by 9. It is 8 by 8 by 8. 8 times 8 is 64, and times 8 again is 512. 512 little cubes still standing in the middle of the block. And you started with 1,000. 1,000 minus 512. 488. That is how many hit the floor. And look how far it sits from the reflex answer. 271 is just over half of it. This was never a near miss. It was a different solid. One number, arrived at by subtraction. It is worth reaching the same number a completely different way, because that is what you would do in the room if you had 30 seconds spare. Count the shell directly. 6 faces, each of them 10 by 10. 600. Except 600 is too many, and you can see why on the block. A cube sitting along an edge, away from the corners, belongs to 2 faces, so you have counted it twice. A cube in a corner belongs to 3 faces, so you have counted it 3 times. So count the pieces in a way that lets nothing overlap. The middle of each face is 8 by 8, and there are 6 faces. 384. The strips running along the edges are 8 long once you leave the corners out, and there are 12 edges. 96. And the corners, 8 of those. 384 plus 96 plus 8. 488. Again. 2 roads, 1 number. In a room, that agreement is worth more than saying the right thing once. Now change the 10 and watch what happens. A cube of side n holds n cubed little cubes. The block that survives has side n minus 2, so the shell is n cubed minus n minus 2 all cubed. Multiply that out and it collapses into something clean. 6n squared minus 12n plus 8. And every piece of it is something you can point at on the block. 6n squared is the 6 faces. Minus 12n strips the 12 edge lines, n cubes each. Plus 8 puts back the corners, which sat on 3 of those lines at once and got stripped 1 time too many. Put 10 in. 600 minus 120 plus 8. 488. Now run the wrong model through the same machine, because it is worth knowing what it actually answers. N cubed minus n minus 1, all cubed, comes out as 3n squared minus 3n plus 1. That is not nonsense. That is the number of little cubes touching at least one of 3 faces that meet at a single corner. It is a perfectly real question, and 271 is its perfectly real answer. Which is what makes this trap a good one. It is not a wrong calculation. It is a right calculation on a question nobody asked. So what was actually being tested here? Not whether you can cube a number, whether you built the object before you started subtracting. The whole failure lives in one word, and the word is both. The shell comes off both ends of every axis. Say that out loud and the arithmetic is trivial. Miss it and nothing downstream saves you, because all that care is being spent on the wrong solid. That is an off by 1, and it is the same slip as counting fence posts along a fence, or cutting a slice out of a list and quietly losing the last item. Everybody has made it. It turns up in interviews precisely because everybody has made it. And that is the part worth leaving you with. Interviewers are not marking the last line you write. They are marking whether you drew the thing before you started operating on it. And they have a sheet in front of them while you talk. 15 years recruiting in finance is where I learned how that sheet gets filled in. So I wrote the version I wanted candidates to walk in with. The Quant Interview Playbook. 411 pages. 4 tracks, because trading and development and hardware and research are not the same interview. 4 mock interviews with the scoring written down the margin. 1-pagers on 24 desks. Link is in the description, and I would go and get the playbook before your next batch of applications goes out. 1,000 cubes. 488 on the floor.